Good morning, everyone, and welcome to this session of mathematics for high school. Today we'll be talking about sine waves, what they are and how you can find them in nature. Now, the first thing you might ask yourself is, what is a sine wave, really? And for that, I would like you to think about the following examples. Have you ever thrown a rock into a pond? If so, you would see that when you throw the rock makes the following waves, right? It's something that expands. Or also, when you hold a piece of string and you move it around, you would see that the string has this shape, right? So this over here is exactly what we mean by sine waves. Sine waves are things that can be found naturally in nature and that are represented by things such as sound, light, and electromagnetic waves. All of these examples are perfect instances of how sine waves can be found in nature. And we'll be learning about sine waves and what they mean. And for that, I would like to present to you the most basic sine wave of them all, the function for sine of x. This function here that you can see is characterized by starting at 0 and having a maximum amplitude of 1. Now, we have learned before that the amplitude is the distance between the maximum and minimum of each sine wave, and in this case you can see very clearly that the maximum and minimum point of the sine wave is 1, or in this case minus 1. Now, sine waves can be represented like I wrote over here with a very simple function, but they can also be presented with a more general function, and the general function for sine waves is the following. F of x is equal to the amplitude of the sine wave times a quantity which is called lowercase omega, which is the period, times time. And that is the general function of a sine wave, this one that you see over here. And we'll be analyzing it little by little throughout the rest of the class. The first part over here is called the amplitude. So the amplitude is, as you have seen here, the maximum and minimum of a wave. So you have the wave over here, and you can see that it's a maximum and minimum. And this is always equal for these kinds of functions. The period here is how long it takes the function to go from one point to the next. And finally, the function of time, which is just what is represented by the progression of the function throughout its course. Please make sure to check the online homework that I have prepared for you, and make sure to address any questions to me at the end of next class. Thank you.